triangle ABC has side lengths AB equals 4, BC equals 5, and CA equals 6. Points D and E lie on ray AB, with AB is less than AD is less than AE. Point F, not equal to C, is a point of intersection of the circumcircles of triangles ACD and triangle EBC satisfying DF equals 2 and EF equals 7. Then BE can be expressed as A plus B root C over D, where A, B, C, and D are positive integers such that A and D are relatively prime, and C is not divisible by the square of any prime. Find A plus B plus C plus D. We have triangle ABC here, with side lengths 4, 5, and 6. Points D and E lie on ray AB, with AB is less than AD is less than AE. Now we have to add in the circumcircles of triangles ACD and EBC here, and their intersection point other than C is going to satisfy DF equals 2 and EF equals 7. And we need to find the length of BE. So the first thing we want to do here is find the length of DE, because that'll help us find the value of BE later. So how can we find the value of DE? We know DF and EF. We just need to get the angle between them, and we can apply the law of cosines on triangle DFE. And finding angle DFE will be easier if we connect point F to the rest of the diagram in triangle ABC. So what happens if we connect point F to point C? Then we can write angle DFE differently here. We can write it as angle DFE equals angle CFE minus angle CFD. And we can find different ways to express these angles using cyclic quadrilaterals. We see that angle CFE is equal to angle CBE because quadrilateral CBFE is cyclic. So we can write angle CBE, and angle CFD is equal to angle CAD because quadrilateral CAFD is cyclic. So we can rewrite this as angle CBE minus angle CAD. Now in terms of the angles of triangle ABC, angle CBE is just pi minus b, and angle CAD is just a. So this is pi minus b minus a, which is just angle C. So the cosine of angle DFE, which we'll use when we do law of cosines, is equal to the cosine of angle C. So let's see what the cosine of angle C is. We have the cosine of angle C is equal to 5 squared plus 6 squared minus 4 squared over 2 times 5 times 6. And this is equal to 25 plus 36, which is 61, minus 16, 45, over 5 times 12, which is 60. So 45 over 60 is equal to 3/4. So let's use 3/4 for the cosine of angle DFE. We have DE squared is equal to DE squared 2 squared plus 7 squared minus 2 times 2 times 7 times the cosine of angle DFE, which is the cosine of angle C, and that's 3/4. Now 2 times 2 is equal to 4, so this just becomes 4 plus 49, which is 53, minus 7 times 3, or 21. So 53 minus 21 is equal to 32, and so DE is equal to root 32, which is 4 root 2. So we've learned that DE is equal to 4 root 2. We can write this here. We are interested in finding the length of BE, not DE. And to do that, we need the length of BD. And to find the length of BD, I suggest we label a new point here. Let's call it point X. It's going to be the intersection of CF and AE. Let's call that point X. So point X here, if you see, it's going to be a big hub for power of a point because there are a lot of other points we can connect point X to and use power of a point on the two circles. So let's do that. We have that CX times XF is equal to AX times XD. Those are both equal to the power of point X with respect to the circumcircle of triangle ACD. But if you notice, CX times XF is also the power with respect to triangle EBC, circumcircle of triangle EBC. So CX times XF is also going to be equal to BX times XE. So AX times XD is equal to BX times XE. let's use x and y to denote the lengths xb and xd respectively. Let's call this x, and this is going to be y. So we can write this ax times xd equals bx times xe in terms of just x and y. So we have ax times xd is going to be 4 plus x times y, and bx times xe is going to be x times y plus 4 root 2. So the values x and y need to satisfy this equation. Let's expand this. 4y plus xy is equal to xy plus 4 root 2x. The xy's cancel out, and we get that y is equal to root 2 times x. So just replacing y with root 2x, all we need to find is x plus root 2x plus 4 root 2, and then we're done. But if you notice, at this point, we can actually get similar triangles. From where, you might be asking? Well, it's because we have equal angles at point x. Partly that, and partly also because the cyclic quadrilaterals. So if you see these equal angles here, those are obviously equal. But so are angle ACX and ADF, because quadrilateral ACDF is cyclic. So we can say that these angles here are equal. And these angles here are also equal. Angle CAD and angle CFD, those are equal because of the cyclic quadrilaterals as well. So we get two similar triangles here. Let's write it out. We have the similar triangles. Triangle CAX is similar to triangle DFX. So we can get some similar triangles ratios. We have that CA over DF equals CX over DX equals AX over FX. But we know CA over DF, and that's equal to 6 over 2, which is 3. So we have CX equals 3 DX, and AX equals 3 FX. So we can write FX is equal to AX over 3, which is just 4 plus X over 3. That's one way to express this length FX over here. But that's not the only pair of similar triangles we have. We also have this one. If you look closely, you'll see that angle CBX is equal to angle CFE because of the cyclic quadrilaterals. Angle BCX here is equal to angle BEF here. So what similar triangle does this give us? Well, it gives us the similar triangles. Triangle BCX is similar to triangle FEX. So we can write BC over FE equals BX over FX equals CX over EX. But we know BC over FE, that's 5 over 7. So what else can we write FX as? Well, FX is equal to 7 over 5 times BX. And BX, remember, that's just little x. So 7 over 5x. So 4 plus x over 3 is equal to 7 over 5x. And we can solve this equation to get the value of little x. So if you notice, 3 times 7x is 21x, and 4 plus x times 5 is equal to 20 plus 5x. So you get 16x is equal to 20 after you remove 5x from each side, and you get x equals 5 over 4. Now, what was our expression for BE? It's x plus root 2x plus 4 root 2. So it's 5 over 4 plus 5 over 4 root 2 plus 4 root 2. And that's equal to 5 over 4 plus 21 over 4 root 2. And that's just 5 plus 21 root 2 over 4. It can be expressed as a plus b root c over d, where a, b, c, and d are positive integers such that a and d are relatively prime, 5 and 4 are clearly relatively prime, and c is not divisible by the square of any prime. 2 isn't. So find a plus b plus c plus d. That's just 5 plus 21 plus 2 plus 4, and that's equal to 32. We are done with AIME problem 13. Thank you for watching this YouTube video. Please follow my channel and help us get to 400 followers before the AIME 1 on February 1.